Hello, today we are going to be going over two volume of revolution examples. Today we are simply focused on horizontal lines. Tomorrow we are going to be working on vertical lines. So first example, we are simply revolving around the x-axis. This is my region and I'm going to revolve it around the x-axis. I'm going to go ahead and show you what that solid looks like. Our solid looks like this, and we, as you learned yesterday, are simply adding up an infinite number of circles, and that's going to help us calculate this volume. So from 0 to 2, we are adding up an infinite number of circles, cross-sections, that will turn into our volume. All right, so I'm going to go ahead and show my work over here. In general, oops, not in. If I'm revolving around, there we go, the x-axis, my formula is going to be pi. We are integrating from A to B. And then I'm going to go ahead and leave this blank. If we're revolving around something that is horizontal, most of the time we're going to be integrating with respect to x. We could also do it with respect to y. Possibly yesterday you might have seen the formula like this. We are adding up pi r squared dr. Notice because pi is a constant, you can go ahead and pull that out of the integral. So for our volume here, we have pi. We are integrating from 0 to 2. We're going from 0 to 2. And our radius here is simply this distance, which is represented by our function. So this will be e to the x plus 2 squared, and then finally dx. And do not have bad algebra when you're typing this into your calculator. Make sure your constant is out here, and then please do not forget your parentheses. We are squaring this entire expression. All right, that is my entire radius. We are squaring that entire expression. I had to yell shame at typically every year I've got to yell shame to a few students because this is what they'll write. This is e to the x plus 2 squared, and then they'll say dx. No. That entire expression is being squared, so pi r squared. For our next problem, we are going to be revolving around a horizontal line that is below our x-axis. So to get a visual of this one, here is what this solid looks like. Yet again, we are still adding up an infinite number of circles to get our volume. So let's go ahead and figure out what would our new radius be here. So for this one, we're going to go ahead and start the exact same way. We have pi. We are integrating from 0 to 8. Now I need my radius. Now I know that this distance from here to here, from the x-axis to our function, this is square root of x. But I also have another part of my radius here. It is simply this constant. This is a distance of 3. So if I'm looking for my total, radius here, well, this is that segment addition that you learned in geometry. I have the value square root of x plus 3. Square root of x plus 3. That value is squared, and we are differentiating with respect to x. So if we have a axis of revolution that is below our x-axis, we are simply adding those two together. All right, now looking at a different type of problem though, let's say that we are revolving around something that is above our x-axis. So here we go, we have x squared is our function, our region is right here, and we are revolving around the horizontal line y equals 4. So to get an idea of what this looks like, here is what this figure would look like. Still adding up an infinite number of circles, but our radius is going to be a little bit different here. So let's go ahead and now that I have a good visualization, let's set this up. All right, so same as always, we are starting with pi. All right, our limits of integration, we are adding up all of our circles. We're adding up all of our circles from 0 to 2. All right, and then finally for our radius, well, our distance from the x-axis, is our function, that is x squared. And I know that this entire distance to our axis is a value of 4. And what my radius is, what I'm adding up, is this distance right in here. All right, so in the previous one, we had segment addition. We had this plus this equaled my entire radius. Well, this is my radius right here. We're gonna have to do segment subtraction. Our entire distance is 4. I'm taking away the x squared, and then that will leave us with our radius. So for this will be 4 minus x squared, and then finally that is with respect to x. So 3 different types of problems here, 3 different types of problems. When we had just around the x-axis, this one was fairly straightforward. This is our radius, is just our function. If we have an axis that is below our x-axis, we are using our segment addition. We have square root of x plus 3. And then finally, our last example is, okay, well, what if we're revolving around something above our x-axis? We have our segment subtraction there. So hopefully this will help you differentiate between those 3 different types of problems. Have a great day.